Welcome back to another episode of Exploring Mathematics. Uh, I was on a walk the other day and I was thinking, how can I explain this coronavirus growth using mathematics? Because we're dealing with two areas. In my head, this is how I was seeing it. I was seeing the exponential growth, and I was also seeing how there's a lot of probability involved because one person meets another person. They don't always pass on the coronavirus. Not everyone gets it, and not everyone meets everybody. So, what's the probability of some people getting it, not getting it? And I thought, how can I make this visual? Well, this morning I opened my email. The National Council of Teachers of Mathematics had an email with this what good visual, a graphic on how you can show different outcomes from the various inputs. So here's what I'm going to do. I'm going to go over here. I'm going to say we have a population of 25 people. We know the coronavirus is, it can stay in a person for up to 14 days without them really knowing it. And it has about a 2.5% contagious rate. Now, let's assume, I'm going to see these 25 people represent their family, okay? One of them is going to have the coronavirus. And what's going to happen in the family, mom, dad, aunts, uncles are all getting together for Easter or for some birthday party. So how does it look? Well, this will role play it many, many different ways. And the outcomes are always different, but they have a pattern. So let's see what's going to happen. This says in 38 days, it'll all be over. Well, what's it going to look like? Okay, there it is. In 30 days, the whole family got infected. In 38 days, right around here, they're adding in, or let me go back a couple days and let's explore what this looks like, what this means. At this point, at day 15, there was one person no longer infected. Well, that's this person right here. Because their 14 days are over, they can't catch it again. They can't pass it on to anyone. Theoretically, they can get it again, but who knows? Some people get the chicken pox twice, right? So what this says is there are 17 people in the family that are contagious. 4 white ones, they haven't caught it yet. The 3 red ones just got infected today. On the next day, well, there's only one person that hasn't caught it yet. And the next day, that person still hasn't caught it, but everyone around them is sick, except for 4 people who are not passing it on anymore. Those are the 4 gray ones. So, by day 25, everyone's in the family has it, and then it finishes off. This doesn't tell us how many people live or die. This just says what it looks like if they, how it passes through the group. Well, it won't always be everybody. Let's calculate again. This one takes 40 days. That one person was sick all by themselves for a long time before they finally got the rest of the people sick. And one person never got sick. That's that one white one. So let's recalculate. 43 days, 41 days, 45 days, 36 days, 40 days, 42 days. How does it look? At day 14, day 15, the first person is no longer infected. But look at this, 11 out of 25, almost half, are infected. And they're infecting others. They're contagious. And then they pass it on and everyone has it. All right. Let's say you don't talk to 10 people. Let's say you have a little bit of a social distancing. Maybe you only talk to 4. Mom, dad, brother, sister, stuff like that. Just the nuclear family. What's it going to look like? Well, in this situation, the one person has it, never passes it on. You're good. Is it always like that? No. 48 days, it can still pass, but about half the people, 60%, never got it because they practiced social distancing with that 4 down there. We can recalculate it. Oh, this one, nobody else gets sick except for the one person. They'll show you that. Recalculate it. This is basically like if this red square meets up with 4 different other squares, rolls the dice, what's the possibility or probability of each of those white squares becoming sick? Well, this is going to take 3 months to play out, 90 days. Watch how it goes. At the end of 30 days, 33 days, 4 people got sick and they're over it. 3 are sick right now and 1 just got sick today. On day 60, 61, 12 of them are over it, 2 are sick right now, and 11 still haven't been infected. So they keep going. At day 90, 1/3, 36% did not get sick at all. 64%, about 2/3, had it, and they can't get it again. So what I'm going to do is, well, what if you have a high school, 900 students? This would be a small high school in my area. Actually, I don't know of any high school in my area that has this few students, but let's just say it's 900. And the kids are going to school, but they're trying not to talk to each other. So it's like you only bump into 4 people a day. What's it going to look like? It's going to be over in 26 days. The one person, does somebody else, yeah, one other person gets sick, and then it's over. So just 2 people have it, and it's done. Now, I don't know about you, but in high school, I never only talked to one person. I talked to all my teachers. I talked to some of my classmates. Maybe there's 20 contacts in a day. The whole thing is over in 42 days, a little over a month. Let's see how it looks. This is one person bringing it into a small high school. On day 15 or 16, the first person is no longer contagious, but look at that, 64% of the school is contagious. They have the coronavirus right now. 11% got infected today, and there's 1/4, 24.6% that have not been infected. Well, let's see what happens by the end of the 42 days here. That is called not bending the curve. Well, the curve is bending now because there's no one else to get sick. Okay, out of this whole high school, 1 person did not get sick. 1 out of 900. Does it always turn out that way? Well, I'm going to recalculate the results. 45 days. Probably the same. 55 days. On day 7, nobody's sick. 8, 9, 10. If he'd have made it to 14 days, he or she would no longer have been contagious and it would have been over. But at day 12, 2 other people and a third just got sick. And now they're going to spread it. That's what this thing means. That's how this works. That's the math behind it. Each of these blue dots is randomly bumping into 4 other dots. They could be bumping into a gray dot. A gray dot cannot get sick again, theoretically. A red dot is already sick, can't get sick again. If a blue dot bumps into a blue dot, well, they can't get sick twice at the same time. So it's only when a blue dot meets a white one now, and there's so few white ones left, that someone new can get sick. So at day 32, we've reached the peak of our sickness and contagious rate. The people are sick, and it looks like everybody got it, 100% this time. And at the end of 55 days, the whole school was infected. Some of them died because this is coronavirus, not out of 900, some people are going to die. So I just want to go over what this visually means. And I'll do one more. What if you cut your contacts in half? Instead of talking to 20 people a day, just 10. It's now a 72-day process. Let's click again. 74-day process. 72. Let's see what 72 days looks like. Yeah, it's spreading pretty quick right now. 1/3 of the school, or this group, it could be a small town of 900. Okay, it doesn't have to be a school. 30% of the people are infected. 1% is already over it. 6% or 7% just got sick today. 36, 40%, 45% of the people are sick right now on day 28. 50%, 54% of the people are sick on day 30. Holy cow. 64% of the people are sick today on day 34. Well, eventually they're going to start becoming unsick by either getting over it or dying. And that's what's happening here. There's fewer and fewer people sick, fewer and fewer people getting sick. Looks like 39 are going to make it without getting sick at all. All right. So this is a simulation on how it works. I could also run a simulation changing it to what if it's a common flu? The common flu is about 1% or 1.2%. I'll recalculate. It's a 147-day event. Oh wait, timeout. They don't, in the common flu, people only stay sick for about 6 days, I think I saw. So I'm going to recalculate. Common flu, 2 people got it, it's over. What if it's a high school where they have tons of friends, they talk to 20 people? How many of these 20 people it's over, 2 people got sick? All right, what if everyone talks to 30 people? Common flu. Now it's gonna be 47 days. This could be a cruise ship of 900 people. Yeah, because too many people are talking to each other. There you go. The downside of being a social butterfly. Right there. 85% of the people had the flu. Flu is far less dangerous when it comes to like killing people. 134 of these 900 people on the ship did not get sick, even though everybody's pretty much talking to everybody else, because 2 things. It's only contagious for 6 days, and actually it could be only 4 days, and has a smaller chance of being contracted, 1.2%. So I hope this helps make sense. I know it's a long video. Take care of yourselves. Social distance. Wash your hands. Wear a mask. Even if it's not for yourself, it's for the other people around you. Okay?